So whenever we start to discuss order of operations, I always like to think about this problem. And I always give my students this problem and I say, do this problem, try it, don't look at your neighbor's board, cover your answer, and see what we come up with. And I give students like a minute to work through it. And a lot of times we get this and we're all happy and good. And that's what happened today when I did this in class. And then I said that Johnny did the same problem and got 16. And then how did he do this? And I always kind of have to, if I don't have that answer show up in class, I have to set it up that way so that we can have this discussion and make sure that we're all on the same page as to why we're going to discuss the topic that we're about to take notes on. So if Johnny were to do this, most of the time my students can say that, well, Johnny did this problem because he added 3 and 5 first, and he got 8, and then he took 8 and he multiplied it by 2 and he got 16, and that was Johnny's answer, except we kind of all come to the agreement that we're not allowed to do that, and it's because of PEMDAS. And then I always have to scold my students and say, listen, PEMDAS has no mathematical background, it has no foundation, it's just a silly acronym that we use to help us remember the order of operations, which is a set of rules that we use that govern how we perform operations in mathematics, so we kind of all come to the same answers. So that's always the lead-in to discussing this topic, and then we just start to take notes on it. And so my students always lead with PEMDAS, and I tell them that instead of GEMDAS or PEMDAS, we're gonna use GEMDAS, and the reason for that is because the only parentheses are not the only grouping symbol that we have. We have lots of other grouping symbols, including the absolute value. We have brackets. We can think of the square root as well as our cubed roots, and then sometimes even fraction bars with our numerator and denominator being 2 separate groups, where we want to get one answer for the numerator, a second answer for the denominator, and then perform that division. So I always start off with the fact that G replaces the P in the acronym students use for grouping. And then after that, from there, it's kind of the standard, well, E represents exponents, and some of the common exponents that we see or usually see are to the second power, which we call something squared, or something cubed, which is to the third power. Let's see if I can erase this and make it into a cubed here. And then after that, we always follow either addition or subtraction from left to right. So addition and subtraction. And I just made a terrible mistake. All of this should come after multiplication and division. So here we have multiplication and division. So multiplication and division. And both of these are performed left to right. And a lot of times my students will want to think, well, I have multiplication and division. I need to do multiplication first because M comes before D in PEMDAS, but that's not the case. So we just need to make sure we clarify that we always multiply and divide from left to right. We always add and subtract from left to right. Just like we would think of, we read a book from left to right, we read equations from left to right, we read lines from left to right. So example number 1 here says 17 minus 5 squared divided by, and then 2 plus 3. I know that's a little blurry, but it is a division symbol, 2 plus 3 in parentheses. So according to our order of operations, we do 2 plus 3 first. That's our grouping symbol. So I always try to encourage students to rewrite the entire problem, even if they don't want to. And I now have 2 plus 3, which is 5. And at this point, we kind of all agree that I don't really need those parentheses anymore, but I have them if I wanted to go back. After that, we look at, well, I'm done with my grouping symbols because I have a single number in here. So I can't really do anything more inside my grouping symbols. So now I'm going to move on to exponents, and I happen to have an exponent, which is a squared. So that's going to be 5 squared, which is 5 times itself. Something squared is something times itself, and that becomes 25. And we said we could drop the parentheses there. So I only have 2 operations left here. I have multiplication, or excuse me, subtraction. We can see I have a subtraction symbol and I have a division symbol. We're going to do the division first. So my 17 and subtraction are going to stay the same. And I'm going to do 25 divided by 5, which is 5. And finally, I'm going to finish this problem off by doing the subtraction, which gives me an answer to 12 for this expression. So that's the first order of operations problem we're going to see. I always point out that we don't have an equal sign because this is an expression. Students haven't earned their equal sign yet, so they don't get to use it. Next, we have this big fraction. I have the absolute value minus 2 cubed plus 20 in the numerator, all over the 10 minus 5 in parentheses multiplied by 1. And I always kind of look at and say, okay, well, what grouping symbols do I have here? I have my big fraction, where the top is actually a grouping. This numerator, the whole numerator is one big group. The denominator is one big group, so I want to try to get the numerator to be one single value, the denominator to be one single value, and then at the end I'll divide. I also have absolute value. I have parentheses. So I always start with the numerator. And so with my numerator here, I have the absolute value of -8. Well, the absolute value is just how far something is from 0. So -8 is 8 in the negative direction from 0. So the absolute value of 8 is also 8. I have a grouping symbol down in the denominator, which is 10 minus 5. So in those parentheses, I'm going to get a 5. And that's kind of all I have with the exception of the numerator and denominator for the grouping symbols. I'm going to go ahead and do one more thing here. I'm going to knock off this exponent for the sake of room. 2 to the third power, well, 2 to the third power is 2 cubed, or 2 times itself 3 times. So 2 times 2 is 4, and 2 times 4 is 8. So this is minus 8 plus 20, and then I have a multiply by 1 on the bottom. So at this point, I'm going to go ahead and rewrite my problem again. I'm going to have 8 minus 8, which is going to be, so I'm going to draw a little arrow here so we know the path I followed. 8 minus 8 is 0 plus 20 in my numerator, and then 5 times 1 in my denominator, well, that's simply 5. And anything plus 0, the addition property of 0, or the additive identity, that's going to be 20 over 5. And now I can simply divide and I get 4. And that's the solution to this expression. And finally, I've got this problem here where I've got brackets, I've got parentheses inside the brackets. I also have some exponents. So I always teach my students to work from the inside out. So go as far in, as nested in as we can, and then we're going to work our way out. So I'm going to start with these parentheses here for 2 plus 5, and then 2 plus 5, I'm going to replace that with a 7 in these parentheses, and I'm going to rewrite my entire problem several times here. Model good habits for my students. So after that, I'm going to do 3 times 7, which is going to be 21, or 3 multiplied by 7, so I'm going to rewrite everything else here. I actually want to look at this exponent, so 6 squared is going to be 36. After my grouping, I'm going to go to my exponents, and I also have 3 times 7. I'm going to go ahead and do that. I'll leave that for now, and we'll do it in the next step. Okay, so now I look in this problem. I have multiplication, implied multiplication with 8 next to this bracket. I have subtraction. Here I have multiplication with 3 times 7. I have division, and I have addition at the end. So I'm going to do my multiplication inside, because once I get inside these brackets, I follow the order of operations. So the next thing I'm going to do is going to be 36 minus 3 times 7, which is 21. And I'm going to do 36 minus 21, which is 15. So I'm going to get 8. 8 times 15 divided by 8 plus 3. And at this point, I had one of my students today pretty impressively say that, well, we can break 15 down into 10 and 5, and 8 times 10 is 80, and 8 times 5 is 40, and so that adds together to be 120. We could also always use our tool on our desk, but it's good to have that mental math skill. So now I only have 2 operations left. I have division and addition. And so if I'm going to divide here first, because I'm always going to do division before addition, I'm going to get back to 15, and I'm going to add 3, and that's going to give me an answer of 18. So lots of steps there, lots of rewriting, but those are the order of operations that we're going to follow. We will do this for more problems here, and we will use our calculator to assist us some for evaluating expressions, but those are 3 examples that we did in class today. Have a great day.